Hey guys, here's day 4 notes, the chain rule and composite functions. Okay, so the definition itself is going to be a little bit weird, like over here. And same with the power chain rule. And I really think it's best once you see an example, it'll definitely make more sense. But let me just try to explain at least the formal definition, and then we'll get into a real example, which I think makes a ton more sense. So if y equals f of u, and u equals g of x, and they're both differentiable functions, which means they are continuous and you're able to take a derivative of, then y equals f of g of x. So essentially I'm plugging this in to here. So it's a function within a function. It's differentiable if dy over dx equals dy over du times du over dx. Okay, which may not make a lot of sense, but equivalently, if I take a derivative of a function within a function, so for example, if g of x is inside f, right, then what we're going to do is we're going to essentially take the derivative of f and leave g inside, okay? So we're going to take almost the derivative of the outside, leaving g inside, and then times the derivative of g, okay? You may be saying, Mr. A, what the heck are you talking about? Let me just make up a random example. It'll make a lot more sense. So let's say I was given f of x equals, and then I had a function like this. Let's make it 4. And let's make this inside 3. No, let's make it 5x to the 5th plus 2x to the 3rd. Let's say I have this as my example, okay? And I want to take the derivative of this. So the chain rule is saying the outer part of this is like f. That's what this stuff in green is. That's the outer part. That's f of x or whatever. And the inner part is in here, okay? That's like your g of x part, okay? So if I actually want to take the derivative of this situation, I'm going to do the normal derivative work that we normally do, but I'm going to have 4 times this inside part stays the same, and that's going to go to the 3. So it's like the same work we normally do with the derivative, where we do that little power rule where this gets multiplied out in front, and then we subtract 1 from the exponent. But because that's the outer function, we also need to work with what this inner function was and have the derivative of that also. What I mean by that is I need to multiply this by the derivative of what was inside. So that would be 25x to the 4th plus 6x squared, okay? So what this chain rule does is you take the derivative of this outside stuff, leave it here, but then we also need to account for the derivative of the inside part, which gets multiplied at the end. Okay? That's pretty much the idea. Okay? And down below, the power chain rule pretty much explains the same exact idea of what I just did. Okay? That example correlates to here perfectly. But let's do a real example. I promise it'll make sense. It's only 3 total to go over. So let's do this one. So it says find the derivative. And I notice it's like a function within a function. This stuff is inside the greater function of something to the 5th power, okay? So if I want to take the derivative of this, what we'll do is we have to do the outside stuff first. So we're going to have 5 times this inner stuff, 3x squared plus 8x minus 7, all to the 4th power. So we do that same work, multiply out in front, subtract 1 from the exponent, right? But we also have to account for the inner part and taking the derivative of this. So I'm going to multiply by 6x plus 8, okay? That's the derivative of this part here. Multiply in front, subtract by 1. Multiply in front, subtract 1 from the exponent, the number goes away, okay? That's your answer using the chain rule. Boom, done, okay? Derivative of the outside times the derivative of the inside. Okay? Easy money, gorgeous, beautiful. Let's do the next page. Oh, Glad that really wrote very nicely. Okay, find dy over dx for y equals the square root of x to the fourth minus 2x plus 5. Okay? The outer part of the function is that square root function. The inner part is everything contained in there. Okay? First off, let's take a different format for this. So we'll write x to the fourth minus 2x plus 5, and that is all to the half power. Okay, so just to keep visuals, this yellow stuff is your f, that's your outer function. The green stuff is your inner function. So if I take the derivative of this, so the derivative of y is going to be that outer part. So it's going to be half, and inside will be the x to the fourth minus 2x plus 5, all to the negative half power, because that's half minus 1, which we talked about last class, okay? So that's just the outer derivative part, times the derivative of the inside, which will be 4x to the third minus 2. That's pretty much the idea, okay? For now, that's just a blanket statement right there. If you want to rewrite this the fancy way, which we've talked about the last couple classes, your final answer will look like this. It's the square root of all that. Okay, times that. So that's if you really want to make it look nice. You could even put that on top and multiply in, and you should be good. Okay? That's the idea. Derivative outside, derivative of the inside. Okay? So those two examples are the best that you need to know. Everything else that you need to talk about for number 3 is more like a conceptual. It's having like a several derivatives, so the first and second derivative, but in more of a conceptual way. So I'll go over that, but really, if you know 1 and 2, you're going to be amazing. Okay, glad that printed nicely. So let's talk about this one. Find h double prime of x, so it's the second derivative, if h of x equals f of x to the third. Okay, so kind of like before, you have the f function, and then you have the g is what's inside. Okay, kind of like Mr. A, I have the g inside of me. I'm just an absolute dog. Okay, h prime of x is now going to be the derivative of this first example. That's the original function, so let's take the derivative. So if I do that conceptual wise, we have to take the derivative of f, so that's f prime, okay, of the stuff inside, right? That's that original stuff. So we're just taking the derivative of the outside times the derivative of the inside, which would be 3x squared. Absolutely beautiful, okay? That's the first derivative. So it's the derivative of the outside with what's inside times the derivative of the inside. If we go a second level, this is where it gets kind of woof and a half. Taking the second derivative, okay? We now have the product rule. We have something times something, okay? If we have something times something, we need to do the product rule. So the product rule states that we're going to keep the original part of f, so we're going to have the f prime of x to the third. All right, we're going to have that original part times the derivative of the second part. So times 6x. So it's this times the derivative of this plus this, the second part, times the derivative of the first, which the derivative of the first part was of this part, and that's going to be the chain rule. So that's f double prime of x to the third. Okay. All right, it's that part times 3 to the x. 3x squared, sorry. Times 3x squared. Beautiful. All right, love that. That's absolutely fantastic. And to simplify our answer, we have f prime of x to the third times 6x plus 9x to the fourth times f double prime of x to the third. Okay? and we are all done. Okay, so if you guys have any questions, let me know. Otherwise, you should be working on the Delta Math assignments. Okay, you have 1 that's due Thursday and 3 due Friday. So 1 due Thursday and 3 due Friday. Okay, get those done. Be good to your subs. Don't be a bozo. Don't be a dingleberry. Be great, and I'll see you guys on Friday. Okay, bye.